Good afternoon, everyone. Welcome back to the online sessions on AWP. And we are continuing with our discussion on the loop antennas. So, in that, we have another loop antenna called as helical antenna. In the previous class, we discussed about the single loop antennas, such as circular loop antennas, rectangular loop antennas, and now today's class will discuss about the helical antennas. So helical antennas are also going to come under the loop antennas. So helical antennas, the size of the helical antenna is normally going to be large in comparison with the other loop antennas. So that is the reason why the four people are really standing here and they are just holding it by a hand and showing it like it's this antenna is going to be a big, very big antenna. Okay, so let us discuss about this loop antennas now. So usually loop antenna is normally going to get placed based on the directivity of the signal which is need to be directed. So loop antennas are normally preferred whenever we wanted to transmit or propagate signal using the circular polarization. So here we discuss about various concepts here on the loop antennas, basic introduction to the loop antennas, working of these loop antennas and various applications of loop antennas, advantages, finally conclusions on the loop antennas. So what is basically a loop antenna? A loop antenna is basically a helical antenna is normally specialized antenna that emits and responds to with a circular polarization or something like a rotating polarized wave. That means when the wave has to be propagated in a rotating fashion or a circularly polarized wave, we normally going to prefer this type of a helical type of the antennas. So these antennas are commonly used at the earth-based stations in satellite communication systems. So whenever you want to transmit some signals to a satellite, now these antennas are normally going to be used with a high directivity. So the center here, what is the basic constructional feature of this particular type of the antenna? The center conductor. Now this is the center conductor that you are seeing here. This longer rod that you are seeing here is center conductor of the cable is connected to the helical element, and the shield of the cable is connected to the reflector. So shield of the cable is connected to the reflector. That means this is the helix actually. So this is the shield is connected to the reflector. This disc you are seeing, this disc is known as the reflector. We call it as a reflector. Okay, so let us look into the various parts of this particular helical antenna. So this particular disc shape is nothing but the reflector base. So we are already using the disc antennas in our house for a television applications. So where you normally going to have a, reflector antenna. So whenever it has to receive some signals, the EM waves are going to get bombarded on this reflector base, and these reflected waves are simply going to get catch up by this particular antenna, and they are simply going to get propagated through this particular helix. So this is what the basic operation when it is normally going to get receive the signals. Similarly, whenever it has to radiate the energy, it is going to radiate energy through this particular coaxial cable. Now this coaxial cable is connected to the transmitter output whenever it works like a transmitter. Similarly, it will be connecting similarly this end is normally connected. That means for a receiver, it is going to be used for wireless communication. For receiver, reflector base is normally going to work out like a receiver for us. Okay, obviously this is once again connected to the this coaxial cable is connected to the receiver when it is using like a receiver. When it is using like a transmitter, coaxial cable is connected to the transmitter end. The next one is going to have a central support rod we are going to have. And here these are nothing but the spacers or support to the helix. So this is the helix that you're going to connect. That means when you wound up a copper wire in a circular fashion, then we normally call this as a helix. So therefore the shape of this is normally called as a helix. Now since the shape of this antenna, this particular loop antenna is in the form of a helix, we call it as a helical antenna. The next one, this particular loop is nothing but the helical aerial element, using which we normally going to radiate the EM waves into the free space. So basic working. What is the basic working of this helical antenna? A helical antenna is an antenna consisting of conducting wire wound in a form of a helix. So what is the conducting wire we have here? So this red one is known as the conducting wire, which is normally wound around this particular central support. So that is what a conducting plate, conducting wire wound in the form of a helix. Next, this antenna can operate in one of the two basic principal modes, normal mode and axial mode. So normal mode and axial mode are the basic operations on which this particular helical antenna is normally going to operate. Well, so let us look into the first normal mode. In the normal mode of operation, now what distinguishes between the normal mode and the axial mode? It is once again the wavelength of the signal that we normally going to transmit with the dimensions of the antenna. So here in the normal mode, what happens? The dimension of the helix are very small compared with the wavelengths of the signal which is normally going to get transmitted. So this antenna typically uses a mobile communication. So normally this antenna used for mobile communications. For mobile communications also we normally going to use this particular type of the helical antenna in the normal mode. Now if you see this, observe this radiation pattern. If the radiation pattern is going to be something like this, which this black radiation pattern is the ideal radiation pattern, and the other red one is normally going to be called as a practical radiation pattern. So that means here this particular normal mode helical antenna is normally going to radiate over 180 degrees. Over 180 degrees is going to radiate, and the radiation pattern is not going to be that identical with respect to the ideal radiation pattern practically. So that is what one of the things, that means the radiation is normally going to get scattered. The directivity is not going to be really very good in the case of this particular normal mode of helical antennas. Then in this mode of helical antenna, next one is going to be axial mode. Now in this axial mode, the helix dimensions are above the wavelength of the operation. So if the wavelength of the if the wavelength of the signal that we are transmitting is going to be more than the helix dimension. The dimension means basically we consider the circumference of the helix under consideration. So if the dimensions are above the wavelength of the operation, it is normally going to comes under the axial mode of the operation. So this antenna, the antenna that falls under the class of waveguide antenna and produces true circuit polarization. So this particular mode simply comes under the class of waveguide type of the antennas and produces circular polarization, produces circular polarized wave. So they are best suited, axial modes are best suited for the space communication. That means if at all we want to transmit some signal to the satellite from the Earth station, we normally going to use this kind of a antenna. Why? Because it is normally going to have a very good directivity. Axial mode is normally going to have very good directivity in comparison with the normal mode, and these signals are going to travel to a longer distances. That is the reason why we normally going to use this type of antenna for the space communications. So especially for communication satellites, usually communication satellites are going to be the geostationary satellites. A geostationary satellite is basically a satellite which revolves around the earth with the velocity of the earth. That means when you really adjust the antenna on the space station, which is going to have a point to point contact with the satellite which is revolving around the earth, then after that always this antenna is which the helical antenna which is there on the earth, which is working in axial mode, is always going to have a point to point communication. So therefore the directivity is really going to be very good in the case of the axial mode of communication. So we look into the patterns now. See the pattern here, the directivity. This is what a directivity. Now the directivity is going to be very good in a particular direction. That means for a geostationary satellite applications, we normally going to turn this antenna towards the direction of the geostationary satellite. So once after we adjust this antenna to the direction of geostationary satellite, always this what is this helical antenna working in axial mode is always going to be in point to point contact with the geostationary satellites orbiting around the earth. Thereby it is normally going to have a very good directivity. See here, this is what the ideal, the black one is going to be the ideal curve of the radiation. It is radiating in a particular direction with very high directivity. So the red one is going to be more practical version. So the practically it is normally meeting to the ideal characteristics of the wave. So therefore this is normally used for really point to point kind of the communications for longer distances. So there are certain specifications given for the practical antennas. Some model has been given here, model 8617810, which is a high gain UHF, high power helical type of the antenna. So it is normally used for satellite uplink conversions. Now there are two kind of frequencies, uplink frequencies and downlink frequencies as far as satellite communications are concerned. What is uplink frequency? The signal frequencies that we normally use to transmit a signal from ground station to satellite, they are called uplink, and a reverse from satellite to ground is going to be known as the downlink frequencies. So for uplinks to UHF frequency satellites, this antenna operates from 236 to 330 megahertz signal with right hand circular polarization with a gain of around 12 to 17 decibels. So overall length is going to be 100 feet for this practical antenna. A special perforated metal cup reflector increases gain and reduces the side lobes. So side lobes are also going to be very less because the directivity is normally improved. Is an improved directivity here we achieve for this type of the helical antenna working in the axial mode. The antenna comes complete with an elevation azimuth pipe amount allowing for elevation adjustments from horizon to 65 degrees. So this antenna can be elevated to a degrees of 65 degrees from the earth station. That means if you take the horizon of the earth is going to be 0 degrees, from 0 degrees it can be inclined to 65 degrees with a appropriate elevation or azimuth angles. So that is how we normally, in order to achieve the perfect connectivity with the satellite, communication satellite, we can have this much of what is this adjustment for the angle of elevation for the antennas. And this antenna can handle up to 1 kilowatt of RF signals, 1 kilowatt of power for the RF signal. So it's going to be a definitely a very high power radiating antenna. See, always remember, whenever we want to radiate signal to a longer distance, you have to compulsorily radiate with a larger power. So whenever we normally going to receive signals from the satellite, we receive signals in terms of millivolts and microvolts. Whenever we transmit signals to the satellite, we normally going to transmit the signals to satellite in terms of kilovolts, kilowatts, in terms of kilowatts. While receiving, we receive in terms of milliwatts and microwatts. While transmitting, we always transmit at a maximum power rating of kilowatts, 1 kilowatts. So that means because we need to transmit signal to a longer distance, to transmit signal to a longer distance, you have to transmit with a high power. So that's where, therefore, this antenna is normally going to support high power radiations also of 1 kilowatts. Then, so this is what the basic shape of the antenna. You can just simply rotate this antenna vertically up around 65 degrees centigrade. You can rotate. Okay. So like this, we can normally use. Now, all the antennas, whatever we use, they are normally placed by considering the spherical coordinate system. As we already know earlier from the earlier chapters, the antenna for in antenna wave propagations, we consider usually antennas are normally placed in a spherical coordinate system in order to get the advantage of theta and phi while transmitting and receiving the signals from the antennas. Okay. Now, after this, what are the basic applications of this antenna? So wherever we need high gain, we normally use this particular type of the helical antenna. And this antenna is normally going to provide wherever we want a circular polarization applications, we use this helical antenna. Now we can achieve adjustable tilt. Whenever we are going to have a tilt in the antenna, we can just simply have an adjustable tilt. Stainless steel bracket, using the stainless steel bracket, you can have a tilt in the antennas. So wherever we have a female N type connectors, we normally going to use this type of antennas. So we can normally prefer use this antennas for applications like DC grounded for lightning protection application also, and rugged lightweight waterproof antenna it is. So it is going to be rugged. That means even though some rain is falling on the antenna, no damage is normally going to happen in this antenna. So the weight is not going to be that high, and it is going to be waterproof. What are the other advantages apart from applications of this antenna are going to be few more now. So this antenna is bandwidth of this antenna is going to be greater because it is going to support the frequency ranges between 400 megahertz 900 megahertz, and it's going to normally transmit signals at a 14 dB, that's 14 dB strength. So that means it's going to have very good gain. Greater gain is going to support, and it will be more flexible. Why? Because we can have different azimuth angles. So that is why it's going to be more flexible, and it is going to be unidirectional antenna. This is what one thing which we have to have. So this antenna is not bidirectional. That means forward and reverse direction signal is not going to get transmitted. Signal is going to get transmitted only in the forward direction. No signal usually won't transmit in the reverse direction. Therefore, it is going to be called as a unidirectional type of the antenna. And the transmission efficiency is going to be very good. Crystal clear transmission is normally going to get supported by this type of the antenna. So a helical antenna is normally used for broadband VHF and UHF applications. These antennas are right hand circular polarized antennas. These antennas are normally operates in one of the two principal modes, such as normal mode and the axial mode. So this is what regarding the helical type of the antennas, basic working applications, and the advantages of these antennas. So with this, we normally end up with this and the textbook for this communication system. So there is a book called George Kennedy. So George Kennedy, this antennas has been given very widely. You can just prefer the electronic communication systems with George Kennedy to understand more about this, antennas, helical loop antennas. Okay. Thank you very much for the today's session.